Greetings, pre-calculus students. If you're watching this video, it most likely means you have already tried the Legend of Gauss problem on your own, and now you are watching to see what the actual solution was. Maybe some of you figured it out. Maybe some of you used a completely different method than the method that I will show here. But first, before we get to the actual solution and the method that he allegedly used, let's quickly look at the problem itself. So one of the most famous legends in the lore of mathematics concerns the German mathematician Carl Friedrich Gauss, 1777 to 1855, whose mathematical talent was apparent at a very early age. One version of the story has Gauss, at age 10, being in a class that was challenged by the teacher to add up all the numbers from 1 to 100. While his classmates were still writing down the problem, Gauss walked to the front of the room to present his slate to the teacher. The teacher, certain that Gauss could only be guessing, refused to look at his answer. Gauss simply placed it face down on the teacher's desk, declared, "There it is," and returned to his seat. Later, after all the slates had been collected, the teacher looked at Gauss's work, which consisted of a single number, the correct answer. No other student, the legend goes, got it right. So that was just a quick read of the problem that you were attempting. So you attempted to find the sum of the natural numbers from 1 to 100 without using a calculator, which is supposedly what Gauss did as well. So let's look at Gauss's supposed method. So this is what Gauss allegedly did to figure out the answer to this problem. So Gauss basically wrote out the series of numbers because it is a sum, right? We talked about this idea in our previous lesson. A series is just a sum of a sequence. So he wrote out the sum like so. So 1 plus 2 plus 3, and then so on and so forth, all the way to 100. So he knew, obviously, that it had to equal a number. So he called this number S, okay? You can obviously call it whatever you want. We know it's equal to something. We know that this sum is equal to something. Well, what he did was he wrote out the sum again, but this time backwards. So he wrote it out like this. So 100 plus 99 plus 98, all the way up to 1. And I think you would agree that this is equal to the same thing, right? Just because you write it backwards doesn't mean it doesn't add up to the same number. And he basically added up these two quantities. Well, if you add up two of the same thing, you end up with two of the same thing. So 2s. Well, what is 2s equal to? Well, you'll see here, and this is why he lined up the numbers like so. He basically added up each pair of number. So we added up 1 with the 100, the 2 with the 99, the 3 with the 98, all the way up to 100 with the 1. And you'll notice that each of those sums are exactly the same. They all add up to 101, right? This is 101, this is 101, this is 101. Everything in between is 101, all the way to the end, which is also 101. Okay? So he knew that twice the sum, or twice the number that he's trying to find, is equal to all these 101s. Well, this is the question. How many of these 101s are there? Right? How many of these are there? Well, we know there are 100 numbers, right? Because from 1 to 100, there's going to be 100 individual numbers. So that means there's going to be 100 of these 101s, right? Because for each of these, when added up, gave you 101. And if there are 100 of them, that means we did it 100 times. So we ended up with 100 101s. So think of this as multiplication, right? If you repeatedly add by something, you can transform that into just repeated addition is just multiplication. So that means we had 100 101s, in other words. So 100 101s, in other words. So we can just multiply that, okay? Well, now, here's one last thing, though. Remember, we don't want to know what this is equal to. We don't want to know what twice the sum is equal to. We want to know just what the sum is equal to, right? We want to know just what s is equal to. Well, that's simple. If we have 2s, but we want just s, just divide it by 2. So all we have to do here is divide this sum by 2. Because remember, 100 times 101 is equal to 2s. So we want to divide that by 2 so we can get just the original sum, right? We just want the original sum. We don't want twice the sum. We just want the original sum. But that's really easy to undo. We just divide it by 2. So that means your answer is going to be 100 times 101. So that's going to be 10,100. We just had 2 zeros at the end of 101 divided by 2. Which gives you, I'm trying to do it off the top of my head, 50,050. And that is the solution that Gauss allegedly wrote down on that sheet of paper that he gave to his teacher. 5,050. Now, obviously, Gauss lived before there were any calculators, so if this story is true, he definitely did it without a calculator. So 5,050, that is the method that Gauss supposedly used. So as you can see, it definitely shows... At age 10, if this story is true, it definitely shows that Gauss had a very good sense of numbers, right? Because he figured out this idea of if I line it up like so and then backwards, I can easily find these sums. And then since they just repeat, I can just multiply it by the number of times they repeat and then finally divide it by 2 to get the actual sum. Okay, so that was Gauss' supposed method. So like I said, maybe some of you got this. Maybe your method was similar to this, not exactly, or maybe your method was completely different to this. But otherwise, that was Gauss' supposed method. So that is the end of this video. Hopefully now you can see how he was able to get the answer allegedly. Otherwise, hope you all enjoy your days, and I'll see you later.